Hello, everyone. My name is Abdallah Al Sayed. I'm an associate professor at the University of Guelph, and welcome to Crosstalk, where we have heavy conversations about light metals. So thank you for joining us today. So first, I'd like to start with a land acknowledgement. So I'm sitting at the University of Guelph, and the Guelph campus is located between the lakes purchase, Treaty 3, the treated lands and territory of the Mississaugas of the Credit. So just to give you a little agenda of Crosstalk today, so we'll have about 15 minutes of questions for our three panelists today. And then we go on to a 5-minute break. And then we go into breakout rooms where you, the audience, can unmute and ask your questions directly to the panelists. So I wanted to introduce the moderators, myself, Abdallah Al Sayed. And then we have Jessica Hiscox at Kingston Metals and Materials. And then Michael Benoit, assistant professor at the University of British Columbia, Okanagan campus.
Hello, everybody. I'd just like to take a few seconds to talk about the overarching purpose of the whole Crosstalk project, which is to create frank and formal discussion between industry personnel and those interested in the experience of working with light metals. Just to let everybody know, this talk and presentation will be recorded. The panel question part of it will be on YouTube, available to everyone later for later viewing. Michael?
Okay, thank you. Welcome, everyone. Thanks for joining us. And also a special thank you to all of our panelists who have taken time out of the day to join us and educate us a little bit on the industry around production of feedstocks for additive manufacturing processes, which of course is the topic of today's Crosstalk, and it's probably no surprise to everyone who's in attendance today. So just a little bit of housekeeping before we kick off with the panel. After the event today, we will be sending around a short survey just to get some feedback. So we'd really appreciate if you could send that or fill it out and send it back to us, just so we can continuously improve these panel discussions. And then looking a little bit into the future. So the topic of today's Crosstalk is on the production of additive manufacturing feedstocks. And in the next Crosstalk session, we will be looking at some of the equipment, processing, and testing around additive manufacturing. And with that, we will now move on to the introduction of our speakers and then kick off the panel discussion.
Okay, so thank you so much. So our first panelist is Javier Arreguin. He's a senior materials project manager at AP&C, GE Additive company. So Javier oversees specialized research partnerships with key AP&C customers. He's in charge of new product introduction for the GE Additive powder portfolio. And then he's also very active in ASTM, ISO, SAE, AMS, and NADCAP committees for standardization and additive manufacturing. He also has a background in physics and holds master's and PhD degrees in material science.
Thanks, Adele. And it's my pleasure to introduce Paul Rometsch, who's joining us from RioTinto, and he's a principal research scientist there. So Paul obtained his PhD in materials engineering at the University of Queensland in Australia. And he's had various academic and industrial positions focused on R&D within the global aluminum industry. So Paul's published widely in the field of aluminum metallurgy, has about a decade of R&D experience with additive manufacturing, both at RioTinto Aluminum and previously with the Monash Center for Additive Manufacturing, which is where I first saw some of Paul's work. So Jessica, over to you.
I'm pleased to introduce Dr. Jose Alberto Muniz, who leads applications research and development at Equispheres Inc., where he champions the industrial adoption of additive manufacturing. Before joining Equispheres, he was a research associate at McGill University, where he was involved in additive manufacturing projects with both aerospace and printer manufacturer OEMs. In his current role, he works with customers and printer OEMs to help them qualify Equispheres powders by providing technical guidance associated with powder handling and processing conditions. He also manages, executes, and reports findings from internal technical projects aiming to reduce the production costs of additive manufactured components without losing quality.
Okay, so thanks so much. I think now we can go straight into the questions. So maybe first one to direct it to Jose. What do you think is cool or interesting about working in additive manufacturing?
Well, first of all, thank you all for being here, and thanks for the nice introduction. So what I think is cool about additive manufacturing on the first thing is that imagination is the limit, right? So additive manufacturing is developing products that they were not able to be built before. So I think that's one of the main things that is making this technology really cool. Now, another aspect of that is that so far, the technology haven't stopped evolving, right? So that makes that even more interesting. So in the last, let's say, 10 to 12 years, we have seen evolution in different aspects. So we have seen changes in hardware, we have seen changes in software, we have seen changes in materials too. For example, at the beginning, in terms of laser powder fusion, we used to see machines with one laser, low powers, that were not productive, and they were actually testing the technology. And then nowadays we have multi-laser machines with high power, and actually printer manufacturers are building machines that have different modules just to improve production. Also, we have seen different laser technologies being adopted. So we have the infrared lasers, we have the green lasers, and now there is a new beam shaping technology there that is really promising, in addition to the high power and another technique there that is splitting the laser and is shining millions of laser shots to improve productivity. Now, the other cool thing of the technology is the software. So 10 years ago, we used to see software that had simple slicing systems where you put your STL file or your CAD drawing, and then it makes the slices, and then it gives you the hatch pattern to print a part. But now we see physics-driven software, which they are actually aiming to improve the quality of the parts and build whatever thing you want in terms of performance at different locations, right? So we see now parts that they don't have supports, which is really challenging to print, and that's just basically driven by all of these technologies. Now, the third part is materials evolutions too. So before we used to see wall-level alloys, titanium, Inconels, aluminums were the most used, but now people is designing new alloys that work with rapid solidification, aiming to create parts made for additive. Yeah, if I have to summarize what's cool, it's basically all of these things. So it keeps me always busy and always learning new what's going on in the technology.
Okay, great. Yeah, Paul, you have anything you wanted to add?
Yeah, thank you for having me. I just wanted to add a little bit on the materials side, because I have a materials background. So I find it very interesting metallurgically. You know, we have a rapid solidification for example, in laser powder bed fusion, and that gives us very different microstructures and very different possibilities compared to traditional ingot metallurgy. So we can consider alloy compositions that we've never considered before, you know, adding elements that are not soluble, not very soluble in aluminium, and we can put them into solution and get unique properties coming out of that. So metallurgically, I find it very interesting. Of course, like it's been mentioned, there's this buzz about it as well. So, you know, a lot of high impact journal papers being published. And it's not just academically, but also in the industry. It's a very dynamic field. There's a lot going on in the industry in terms of conferences, industry meetings like Form Next, for example, and also like magazines coming out, like just the metal additive manufacturing magazine. It's, you know, it's got more than 200 pages, and there's always something new coming up. So I guess people were very excited about the prospects that additive manufacturing can bring, also in terms of reducing waste, reducing lead times, avoiding tooling, reducing weight, reducing materials and energy consumption, and coming up with you know, complex geometries. So yeah, just a few thoughts there. Thank you.
Yeah. Javier, if you wanted to comment as well.
Yeah, thank you for having me. To me, what I find interesting for IT manufacturing is that you are able to think out of the box. A lot of things we know, and a lot of engineers has been taught how to make the things in that traditional way, but now the IT manufacturing bring a new technologies, a new way to do the things, and then you need to challenge yourself what you learned in the past and how you can adapt what you learn to the new technologies. So to me, it's very, very interesting, because right now, for example, all the parts that we are making in IT manufacturing, I will say, if not all, close to the 100% parts, are thinking to replace parts made by traditional manufacturing process, because this part has been already approved, has been already validated. And for example, for aviation, the engines were designed thinking based in the manufacturing technologies available at the time. With the new generation of engines in the future, that will open a lot of possibility to the designer, adding a new technology for the design of the parts. So the parts will not be only replacement of complex parts to make it simple, or to consolidate multiple parts that were made with different technologies in one part of additive manufacturing. The whole engine could be thinking differently. I'm not saying the whole engine will be designed for IT manufacturing. What I'm saying is that it will be possible to think the engine in a different way, how it could be more performant, because you can make parts in a different way from the designing from the beginning. That is what I find really interesting for the technology, that give you a lot of new tools for the new generation of the final parts, of the airplanes, of the spaceships, a lot of different things. The difference is that we need to think out of the box. And that is why I believe is very, very interesting of IT manufacturing. For materials, there is too many challenges in the material that need to be still accomplished. Yes, we could add new alloys, new materials that will perform better, but we need still to improve in what we have right now. We need to continue design new alloys, but we need to understand how to make efficient what we have until now. That is what I think.
Great, yeah. Thank you.
Thanks, Javier, and everyone. And I think that what Javier has just mentioned leads us very nicely into our next question. So the next question here is, I want to hear your thoughts on what some of the major challenges are when it comes to the production or the development of additive feedstocks. And these could be challenges on the technical side, economic, logistical, social, et cetera. So whatever challenges you see to the development or production of feedstocks. And Paul, maybe we'll start with you.
Thank you. So perhaps starting with some technical challenges. Well, first of all, you need facilities that can handle powders. If we're talking about powders, I mean, there are wire forms of additive as well. So depending on what you're into, you need the right facilities and the right equipment to be able to make that feedstock, to be able to handle it. And then there is the materials aspect, coming up with alloys that give good performance in terms of printability, but also in terms of the final properties, and then having a consistent product. So it's performing in a consistent way, giving the same results each time. Of course, we need very good control of the chemical composition and the control of the impurities, as well as the powder characteristics, like how spherical they are, how well they flow, what's the particle size distribution, and so forth. In terms of maybe the other guys can talk a bit more about those aspects, but in terms of the chemical composition, one interesting thing is standards. To get that consistent result, there's been a focus on developing new standards. And I have been involved, for example, with the Aluminum Association, developing the purple sheets, which is defining the chemical compositions of products, of alloys, registering aluminium alloys that are in production. So that's an interesting development. Economically, I would say the high cost of the powders is still an issue. Some of the atomization processes give very broad particle size distributions, and then there are low yields because the fines have to be sieved out, or the coarse particles have to be removed. And this raises also challenges in terms of waste. What do we do with that material? Can we sell it to some other form of additive manufacturing that takes a different particle size distribution, or can we recycle it, or can we come up with better atomization technologies that way you don't get so much waste? In terms of logistics, supply chain issues, I think it's important as much as possible to have a local supply chain, a local value chain, and looking towards recycling. I think one of the challenges also is the explosive nature of some of the alloys, some of the powders, and how can we ship and handle them and store them? And coming back to the social aspects, that kind of ties in a bit with that as well. The safety aspect, the environmental aspects, improving the sustainability. Can we have an environment where people don't have to wear a full suit, a full breathing apparatus or masks? Can it be a clean environment? And things like this are ongoing areas of discussion. So thank you.
Right, thanks. Very comprehensive and speaking to all different types of challenges. We'll go to Javier. Do you have anything to add in terms of challenges to production or development of powders?
Yeah, sure. I think Paul make a great overview of the challenge that we have. Really, he covered everything. I would like to summarize my point of view in two main challenges for the powder itself, for IT manufacturing. The first one is the batch-to-batch reliability. For IT manufacturing process, there is a lot of different variables that may affect the final part properties. It could be the laser, it could be the machine, it could be the post-processing, a lot of different things, including the raw material. If the powder producer are able to always produce and ship batch-to-batch consistency to the final user, they can bring out of the equation the raw material as a variable and can focus on the rest of the process. So I think that is a main challenge that the powder producer we have to always to provide batch-to-batch consistency for the material that we supply. Second thing that I think very important, I'll also mention, is that safety. Powder are reactive, powder can be explosive. We need to work how to make the powder more safer, how to handle the powder, how to develop the correct strategies to handle the powder in a safe way in order to make it safe for the facilities, but for the employees, for all the people that will use the powder. That is a big challenge for on the powder side. I think also that the recycling is very important. As Paul mentioned, the powder is costly. If the powder is getting out of the specification very quickly, you can use it just some limited number of cycles in the machine. If you cannot use it more, this powder, at the end is a waste. And it's not only a waste in money, it's also a waste on all of the resources that has been used in order to produce that powder. So we need to extend the life cycle of the powder by developing correct the strategy for the recycling that guarantee the final parts property in order to increase the life cycle, to reduce the pollution generated for the powder itself. That will help one of the main objectives of the technology, that is to have a technology that is cleaner than the traditional manufacturing, and also it will impact to find the business case for new application of additive manufacturing.
Right, perfect, thank you. And Jose, did you have anything to add to what the previous two said?
Yeah, Javier and Paul cover most of the things that I had in my mind. I will add only one, I would say, and I think it's from the social perspective, I think finding people to keep operations running smoothly is challenging, right? So quality is important, so we need to ensure that consistency and quality of the powder, the consistency and the quality that the powders needs to have access to high-skilled workers. So if I have to summarize the main point that I think is really, really important, like really close, will be is the production of feedstock. We need to ensure consistency and quality required to have a consistent AM process while we reduce the cost of the production. I think that's the main challenge, in addition to all the others that were already mentioned.
Perfect. Well, thanks, everyone. I'll turn it over to Jessica for the next question.
Well, Jose, you gave me the perfect lead in there. You mentioned briefly personnel. Our next question is, especially given that I think part of our audience is going to be students or people considering different industries to move into, what sort of skills, whether they're personal or technical, would allow someone to succeed in the powder metallurgy industry? What do you think is important?
I think it's a really good question, right? So I have some of them. I'll mention what comes to my mind, and then it can be complemented with other things. But I think what we need in the community is to be humble, and we need to be willing to learn, right? So this is a technology that is a multidisciplinary. It requires many types of different knowledge that is just impossible for one single person to know all the aspects of the technique. So we have to be humble on that, recognize that we know a small portion of what we see, but there are other things that we don't see and we can learn. So I think that's a skill that all the community needs to have. The second one was mentioned by Javier at the beginning, and I think is we need to have design skills, creativity, and thinking or to think out of the box. So this combo of skills is really important because AM up to some time before, probably now has changed a bit. People was trying to adopt the technology for the designs that already exist, right? So just as Javier mentioned. So we need to have people that have this combo, this creativity, this good design skill to actually open the bottle, because right now it's closed with what exists. So we need to open the bottle to allow new designs to come into play that are actually designed for AM and that are actually designed for performance, right? So before it was designed for performance, but considering the machine capabilities, right now it opens just a wide range of opportunities in which we have the chance to design a system or a product thinking on how we want that to perform. If I have to add another one, I would say knowledge of materials is important. So we have to understand what happens with our materials, how the microstructure changes. If we have to do heat treatment, if heat treatment is needed or not, and it depends on the alloy chemistry and a bunch of things. We don't need to know everything, but we have to have a sense of how it works so we can learn from that and construct. The other two things, skill that I think are needed is teamwork and a sense of commercial perspective, right? So the nature of being multidisciplinary, we need to have a multiple collaboration to achieve what the company wants or what we want to achieve. So it's really important to know how to work as a team. And I was a graduate student for a few years. And as a graduate student, we are taught to understand phenomena and then apply that understanding to improve it. But I think there is a lack of a commercial perspective. So we can create business cases and then we can sell those propositions. So in overall, it's a big combo, but I think that's what I think that skill will help people to actually join the AM community and make it to grow.
Thank you, Jose, for that really great overview. If either of our panelists have something to add, or we can move on to the next question.
Yeah, I can throw in something. I really like that, what you've said, Jose, there about being interdisciplinary and being open. I think we have to be curious and innovative. This is a rapidly changing field. So, and this comment about thinking outside of the box, I think even just looking at the materials, I think it's good to think outside the box for the materials, the alloys we're developing, rather than just borrowing alloys from, you know, existing cast alloys or existing wrought alloys, because they don't necessarily work or they don't necessarily give the desired results. So thinking outside the box, and yeah, multidisciplinary is a big word here. So many fields, not just materials. I think for developing alloys, certainly materials is very important, but when it comes to the whole additive industry, there's a whole lot of different skills that are needed, all the different types of engineering and science. So thank you.
Yeah. I would like to comment as well. I think Jose and Paul cover very well the necessary skills that new people need for the technology. But as Jose say, we need to think out of the box. We need to be curious, because one of the main problems that I face very often in IT manufacturing field, working with customers and working with the final parts, is that the engineers that exist right now in the industry take the IT manufacturing part and try to explain the behavior of this part based in the knowledge that they have for casting or raw materials, which is totally different. Because when you see the metallography inside of the material is very different from the casting and very different from the raw material. And sometimes there is a big gap in the understanding for the engineers, what you can get from IT manufacturing and what you can get from traditional manufacturing technologies. So fill this gap is important. New generation need to be ready to know what is the difference with these two technologies and how understand correctly the properties that you are analyzing based in the new technology. Until now, you can see in most of the textbooks is always based in casting, in forging, and all traditional manufacturing technologies. It coming more and more new material books with IT manufacturing, but still there is this gap. So it's very important that the new people is curious to identify this gap and go to learn by themselves by looking in papers, but looking in new publication, wherever they can find information in order to understand correctly the material behavior based in the technology, how this material has been prepared. So I think that is important.
Great comments. Our next question is similar. It is about regarding, but I think our panelists have really addressed it well. It's the gaps regarding personnel, and more on that kind of the technical side. But I think all of you kind of addressed these quite well. Maybe if anyone else wants to comment, otherwise I think maybe we go to the next question.
I think maybe skip that one and then move on to the next one.
So I guess, so that's me, I guess. So we're right here. So I guess one question, I think some of you already touched on this in some of your earlier answers, but one question, as we look toward the future, what's one thing that could be done to help make the production or development of additive feedstocks more sustainable? I guess, Paul, maybe we can start with you again.
Thank you. So any material that we use, it comes from somewhere, and producing it requires that there'll be an associated carbon footprint for the raw material. So we need to consider where it comes from, how it's made, what's the carbon footprint, what can be done to improve it. Then here I'm talking, for example, about aluminium. Producing the aluminium in the first place, the smelting process, for example. After that, there's the question of how we produce the feedstock itself out of the raw material, and what's the carbon footprint associated with that, and what energy goes into that, and what waste does it produce? I've already mentioned before, there's some waste from the atomization processes. Waste in additive manufacturing itself, can we recycle the powders in any way? Can we reuse them more often? Are we able to recycle not just parts that have been built or support structures, but also the different types of powders? And can we put that into sort of a type of a closed loop recycling type of a value chain that is as local as possible, so there's less transport, and hopefully less material involved in the end. From the RioTinto perspective, I just wanted to throw in, big aluminium companies making aluminium like RioTinto are looking very much into reducing the carbon footprint. So for us, for example, we're using hydropower. So we have 3 times lower CO2 footprint than the industry average, just because of that in the smelting process. Then there's other things that are going on, like thinking outside the box. There's this ELYSIS carbon-free smelting technology that's coming on board. There's a lot of developments in the aluminium industry in general around, for example, the Aluminium Stewardship Initiative, certifications that guarantee transparency over the whole value chain, including environmental, social, and governance criteria that are looked at there. And responsible aluminium having a traceability through the whole value chain. So we have initiatives on that, and companies are increasingly moving towards net zero carbon as much as they can, including RioTinto. As far as additive manufacturing goes, a lot of companies have signed up to the Additive Manufacturer Green Trade Association, AMGTA, established in 2019. To promote the environmental benefits of additive over traditional manufacturing. So there's a lot of useful resources on there as well, including life cycle analyses, literature, and just basically making comparisons. And so it's very valuable to look into all of this and see what can really be done on the sustainability side.
Yeah, perfect. Thanks so much, Paul. Let's go to Jose first, maybe see if you have anything to add to what Paul's said. Things that we could do to be more sustainable.
Yeah, thanks, Paul. Well, again, AM is multidisciplinary, right? So I think being sustainable, it doesn't involve only the feedstock manufacturing. I think it involves the whole supply chain, right? So I think we need to work with users. We need to work with standards committees, and then we need to work with the feedstock for the atomization process. Now we need to increase. I think we need to increase the tolerances to impurities, so we can use reused or we can recycle materials into the atomization process, that's gonna help to reduce the carbon footprint. The other thing I think is that we have to improve the atomization processes. We have to engineer them, make them better to increase the yield, right? We cannot excuse always saying that this percentage of yield and that's what it is. Like we actually have to work on that to make it better. The other thing, and Paul mentioned that, so the higher amount of energy consumption in the process is the energy required to melt the material, right? So I think adopting green energies, just as RioTinto is doing it, is great, because that's the way that everyone can reduce or put a little bit of effort on being more sustainable. And I would like to add a new point. Now, if we put in the field and we assume that additive manufacturing is going to be adopted in the future, it will require alloys, right? So we need to design new alloys. The new alloys will come. I'm 80% sure that new alloys will come, right? So what we have to do on that is that we have to think right now on this time how to design those alloys, because no matter what element we put on those alloys, we have to think what we're going to do at the end of their life, right? So it's not only to think on performance of the material we are designing. It involves more what is the energy required to extract that alloying element that I'm going to use in this material. Is it good or it's not good? Then when the part is printed and it reaches to the end of the life, are those alloying elements can be recycled again into the same high value composition, or is going to be downgraded into a low cost, low value alloy? So I think that thinking has to be in place for AM as it was placed for the design of alloys for aircraft back in 10 years ago when I was doing my PhD. That was one of the topics. Like people was designing the new alloys for the new aircraft to be closed loop. And I think we have to do that for AM at some point.
Perfect. Thanks, Jose. And Javier, anything to add in terms of sustainability?
Yeah, I think Paul and Jose cover almost everything, and I agree totally with both. We need to select a supply chain that is close to the final user, ideally, a supplier that use green energy, like plasma optimization, like the HSFER or AP&C that we use renewable energy. So that helps. It's totally different to a powder producer that produce, let's say in USA, that use a carbon energy. That the footprint will be totally different. One last point that I would like to add in the sustainability is that we also need to think in all the consumables that we use during the powder production and during the shipping. For example, one of the challenges that we are always working with the customer is how we can improve the packaging. For example, if a customer asks for 1 ton of powder and we ship in 1 little container of plastics, at the end that will be a bunch of a 1 liter plastic container that will be just waste, and it cannot be even recycled, because that will be some metallic powder in the inside of the container. That will be something that will have a big impact in the footprint of the material. These kind of things we need to also to consider, how we will to ship the material, how this will impact in the pollution that we could generate for the powder fat. As Jose says, not only the powder, is all the ecosystem that is around of the powder that we need to rethink how we can make it more sustainable in order to reduce the footprint of the raw material.
Yeah, well, thanks so much, guys. I think I'll turn it over to Jessica, the next question.
Yeah, thank you for that interesting discussion. Our next question is very speculative, so I'd like our panelists to get out their crystal ball and say, how do you think additive manufacturing will change in the next 5 years? I think I'll get Javier to start us off on that one.
I think it's very difficult to think. If you make me that question 5 years ago, I will not even imagine we will be in the place that we are right now. What I can see from now is that it will be more new technologies that will join the additive manufacturing. Right now, we are talking a lot of powders and powder bed fusion, but there is a lot of different technologies for additive manufacturing, even in metals or other type of materials. But so that will be new technologies that could be very successful. We don't know. That could be new material. There is a lot of effort designing new alloys that could be more performant or more adapted to additive manufacturing technologies, because the materials that we are using now is materials that has been developed for casting and raw materials and not for additive manufacturing. So the people now are thinking out of the box how I design the material that is adapted for additive manufacturing for the rapid solidification and to get the best mechanical properties. So that is the thing that will coming. Something that I found very, very interesting is that, as I mentioned at the beginning, one of the main markets of additive manufacturing, at least for metal additive manufacturing, is the aviation side. And what we are doing right now in aviation, as I mentioned, is that we identify parts that could be consolidated and make it easy by additive manufacturing, instead to have 50, 60 different parts to make one part in one shot, and that make up a real business case. What I found interesting is that was based in the old design. New generation of engines will be different. That will be new tools for the engineers, and that will bring new opportunities for the designer, for the material science, in order to make the material more performant, the final component of the engine more suitable for the technology, and to take really advantage of the additive manufacturing capabilities. We need to look also very close to the space market. We saw, I think every day we saw in the news a new launch for Blue Origin, a new launch for SpaceX, and a lot of different plans for Elon Musk to go to Mars and all this kind of stuff. There is a lot of challenge over there. One of the main things to make that successful is to be able to have a metal 3D printer in the spaceship. How to make to be able to make the parts in the space. And the people is already working on that to see how we can adapt a printer that could work very well in the space, and we can make the tools we may need once we are in the space. So that is a lot of different challenge that is coming, and I think just trying to imagine, very difficult, that will be the future in the next 5 years for additive manufacturing.
That's a lot of interesting ideas. Thank you. Would either of our other two panelists like to chime in?
Yeah, I can add a little bit here. Good comments so far. As far as laser powder bed fusion goes, with one laser in a machine, in a small machine, the way it started out, the build rates were very low, less than 25 or 50 cubic centimeters per hour. So in the future, there's more, the machines are already getting much bigger, having more lasers in them, being able to build at a much faster rate, and that envelope is just going to be pushed higher and higher to make it more competitive and to kind of go in the direction of series production, but it's still not a high volume production method, but it's sort of moving into that direction. So one thing that could also contribute to that is to have larger additive manufacturing facilities with larger numbers of printers just in rows in buildings, and each printer being dedicated to a particular alloy, to a particular product. So you have rapid turnover and less waste of time and issues. So instead of, you can imagine like a machine shop, like a CNC machining shop. You have all these CNC machines in a row, but that's subtractive manufacturing. Here we're talking additive, doing the opposite, but the same sort of thing. That would be that's a possibility, and it's sort of starting to happen. I like the point that was made about new printing technologies. So, you know, we're starting to see aluminium being explored for binder jetting, for example. And previously this was an issue because of its explosive nature and challenges in handling the powder. But there are more and more technologies coming out for additive manufacturing, even liquid metal printing, and hybrid systems coming out. So trying to achieve higher build rates and managing this sort of trade-off between build rate and then the tolerance that we get. When we're considering different printing technologies that are coming out, I would like to add also that the design of the alloys will probably need to be different, because different printing technologies have different solidification rates. Some of them we're not even talking about solidification, like in binder jetting. So the design of the alloys is going to be different to get the maximum out of them. So there's an interesting thing to consider for the future. Thanks.
Yeah, I would like to add a few things too. I don't think the technology will change if you see it in a different way. I think it will be the same, and people will keep pushing the boundaries. So as of now, we have seen it changing, but I think it's gonna be the same. So it will constantly be changing as of now, right? So if you think about it, now that people realizes the benefits of the technology, big OEMs and new startups are now trying to unlock new materials and new applications, right? So these efforts are being done now. So by 5 years, I think all that work, all those funded projects will materialize. I'm really hoping to that. But all these space agencies are really pushing the technology into that kind of level. So that can happen probably in less than 5 years. Other thing, I think there will be more maturity in the adoption of the standards. I think more standards would be written, more people will have access to them, and that will help to go into production. I also think that there will be more skilled people, right? So if you go to those shows, the AM, the additive manufacturing shows, you see a lot of young people out there. So I think we have significant amount of people with good design skills and a better understanding of what they can do. Just having access to plastic printers, right? So that just totally changed the way of thinking, and then it can be extrapolated to different technologies. So I think that's gonna come. Yeah, and the other point I have is the productivity that Paul already mentioned to it. We're gonna have more automated, bigger, and more robust systems. Yeah.
A lot of interesting ideas there.
Yeah, so thank you very much. I hope the panel discussion and then the breakout rooms were very beneficial for you. Thank you everyone for joining. Thank you for our panelists, Javier, Jose, and Paul. Thanks for the moderators, Michael and Jessica, and then Joshua, who is in the back, moving everyone around and making sure everything ran smoothly. Thank you for everyone for joining us at Crosstalk. We'll have the part 2 sometime in the new year, and hopefully you can join us for that one too.
Bye, everybody. Thank you very much.
That one will be about the additive equipment.
Yes,
so.
Yeah.
Thanks for the invitation.
Great. Thank you.
Thank you very much.
Thank you so much. Have a nice afternoon.
Very soon. Thank you. Bye-bye.